This is Unit 5, Day 1 Notes, Properties of Exponents. So all of this is actually a review of Algebra 1, so this all should seem very familiar to you because this is all stuff that you have done before. So again, this is all a review of Algebra 1. So to start with, if I'm given this, 4x squared, what is the base that goes with the exponent of 2? So you have to be really careful with parentheses when we are dealing with exponents. So the exponent only applies to what it touches. And if there's no parentheses, it's only what it directly touches. So in this case, the base that goes with 2 is just the x, not the 4. Now, if it was written this way, 4x squared, that would be different. It would apply to both of them. But right now, it's only what it touches, so it's only the x. So quick review. When we add and subtract with exponents, we are just combining like terms. So for example, 3x plus 4x. You add the coefficients, 3 plus 4 is 7, and you keep the variable exactly the same. You don't change the exponents on the variable. Or maybe I have 5y squared minus 10y squared. 5 minus 10 is negative 5, and we keep the y squared. The zero exponent rule says anything raised to the 0 power is 1. So x to the 0 is 1. 5 to the 0 is 1. X to the 0 is 1. The negative exponent rule, basically we don't want to see negative exponents. So to get rid of a negative exponent, you flip sides. So if I had written this as a fraction, I would take this x and put it from the numerator down to the denominator. And that's what makes that a positive. And then of course I have to have something on the top. I can't just have nothing, so I would have a 1. So for example, 5 to the negative 1. The 5 right now is in the numerator. I'm going to switch it to the denominator, make that 1 positive, and of course I'm going to keep a 1. Or let's say I had 1 over x to the negative 2. In this example, my negative is already in the denominator, so I'm going to move it to the top, to the numerator, and say x squared, and I don't actually have to put it over 1. We don't have to say x squared over 1. We can just say x squared. So the negative exponent flips it. If it's on the top, it moves to the bottom and becomes positive. If it's on the bottom, it moves to the top and becomes positive. Product rule. This only works if you have the same base. So in this case, my base is x, my base is x, it is the same. So we keep the base and we add the exponents. So a plus b. So 5 squared plus 5 to the third is 5 to the 2 plus 3, which is 5. Or if I put this in my calculator, 3,125. Oops, 125. Or I might have x to the fourth times, oops, when I wrote plus there, it should be times x to the seventh. Keep the base is x. 4 plus 7 is 11, so my answer is x to the 11th. Power rule. This time I'm going to multiply them. So it's x to the a times b. Or if I had 5 squared to the third power, 5 to the 2 times 3, which is 5 to the 6th, which is 15,625. Or maybe I have x squared to the fourth power. 2 times 4 is 8, so x to the 8th. My quotient rule, so if I add them from my product rule, think about quotient, I'm going to do the opposite. I'm going to subtract them. So I would have, again, you have to have the same base though. So same base, keep the base, and subtract the exponents. So let's have x to the 8th over x squared. I keep the base, which is x, and 8 minus 2 is 6. And you want again, you don't want negative exponents. So if I had something like this, if I had x squared divided by x to the 8th, my answer is going to go on, we're going to decide if it's on the top or bottom based on which is bigger. So 8 is bigger than 2, so I know my answer is going to go on the bottom on this one. So 8 minus 2 is 6, and I have 1 over x to the 6. On this one, my 8 was bigger and it was on the top, so I know it's going to be on the top. So again, no negative exponents. And then lastly, when I distribute, so this is one big set of parentheses here, x over y to the a means I am raising the x to the a and also the y to the a. You're distributing it to everything in the parentheses. Same thing here with multiplying. I'm distributing the a to the x and the a to the y. So an example of this would be something like x over y squared. It would be x squared over y squared, or xy to the fourth. X to the fourth, y to the fourth. So those are your rules. If you forget your rules, remember that you can always expand to help you try to remember them. For example, my product rule, 5 squared times 5 to the third, or actually let's do x. X to the fourth times x to the seventh. Let's say I don't remember. Am I supposed to multiply? Am I supposed to add? I don't know. Well, x to the fourth is the same thing as x times x times x times x, right? 4 x's. And x to the seventh is the same as 1, 2, 3, 4, 5, 6, 7 x's. Well, when I count them all up, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is x to the 11. And that sometimes can help you remember, oh, I need to add them when I multiply. Same thing with this problem, x squared to the fourth. So if I expand x squared, that's x times x to the fourth. To the fourth means I do it 4 times. So x times x 1 time, 2 times, 3 times, and 4 times. And now when I count these up, I can see 1, 2, 3, 4, 5, 6, 7, 8. It's x to the 8th. I can do the same thing for division. Let's say I have x to the 8 over x squared. If I expand x to the 8th, 1, 2, 3, 4, 5, 6, 7, 8, and x squared, 1, 2. Whenever you have the same thing on the top and bottom of a fraction, you can cancel. So cancel, 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 and I have 1, 2, 3, 4, 5, 6 left, which is x to the 6th. So remember that expanding can help you do the problem or remember the rule. So if you're a little bit stuck, try to maybe expand and do it that way. All right, the backside, basically to sum this up, when you multiply 2 exponents with a common base, you add. When you raise a power to a power, you multiply. So the point is here, do not multiply the exponents when you're multiplying 2 expressions. So kind of try to put that in your head that you're multiplying with the same base, but you're not multiplying the exponents. And same thing with power to a power. You're not raising the power to a power. For the exponents, you're multiplying the exponents. All right, so these problems right here, check the answer key on Blackboard. They are all worked out. I'm not going to talk through all of them, but check your answer key, look at your rules on the front, and if you need to, work on expanding.